Today we are talking about lesson 31, flowchart proofs and paragraph proofs, and this is part 2. So the question for part 2 is prove the vertical angles theorem using a flowchart proof. So here we're actually being asked to use a flowchart proof. We are given that A and B are intersecting lines. So now let's think about why we would want to use a flowchart proof. So flowchart proofs are useful when a proof has two different threads that could be performed at the same time rather than in sequence with one another. Whenever a proof does not proceed linearly from one step to another, a flowchart proof should be considered. So if we look at this example, we have that we are given triangle ABC, and we are trying to prove the triangle angle sum theorem, which is that the sum of the interior angles of a triangle is 180 degrees. So we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 180. If we look, this one step has 3 arrows coming off of it. That means that we have 3 different things that come from this one single idea. So it first starts off with draw a line, line A, that is parallel to line CB that goes through A. So we start off with that. And we can say that because it's parallel, so we are constructing that line. Now we have angle 1 is congruent to angle 4. So that's this angle here is congruent to this angle there. Well, we know that because we're on alternating sides of those interior angles. These are both on the inside of our 2 parallel lines. So we know that alternate interior angles are congruent if the lines are parallel. And we know that the lines are in fact parallel. We also know over here that angle 3 is congruent to angle 5. So we know that this angle is congruent to this angle here. The reason we know that is, once again, we have the alternate interior angles theorem. So this side, these 2 angles, they are on alternating sides and they are on the inside of those 2 lines. So because of the alternate interior angles theorem, we know that the measure of angle 1 is equal to the measure of angle 4. This is because of the definition of congruent angles. By that same definition, we have the measure of angle 3 is equal to the measure of angle 5. Now, because we have line A going through A, that means that this angle plus this angle plus this angle make a straight angle. So we have the angle addition postulate, which says we can add angles together and the new larger angle is equal to the sum of the 2, or in this case 3. And the definition of a straight angle, well, that's the equals 180, because we know it's a straight angle because it forms a line. So that means that angle 4 plus angle 2 plus angle 5 is equal to 180. Now we use this piece of information here, angle 1 is equal to angle 4, to substitute in the angle 1 for angle 4. And we use that same piece of information to substitute in angle 3 for angle 5. So we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 180 degrees. And for that, we're using the substitution property of equality. Just switch that in, swap that in. So now, it's asking us to prove the vertical angles theorem using a flowchart proof. We are given that A and B are intersecting lines. So we need to say that A and B are intersecting lines. How do we know that piece of information? Because it has been given to us. The first step in proof is given. Now, this tells us 2 things, that we have angle 1 and angle 2. Angle 1, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. We know that because of the linear pair, the definition of linear pair. We also know that angle 2 plus angle 3 is equal to 180 degrees. We know the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. The reason for that is that angle 2 and angle 3 make a linear pair. That is the definition. So now we can combine these two things to say that measure of angle 1 plus measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. So we can set those two equal to each other, and we are going through 180 to do it. So that is the transitive property of equality. Now we have the answer that we were looking for. Not quite, but we have close to the answer we're looking for. We have measure of angle 1 is equal to the measure of angle 3. We got there because we were subtracting angle 2. So subtraction property of equality. Now, if we have two angles that have the same measure, that means that they are congruent. Angle 1 is congruent to angle 3. And that is the definition of congruent angles. That's the end of part 2. I hope to see you in part 3 very soon.